Hello, everyone. Thank you for joining us today. Hello, Mesut. I'm happy to see you here.
Hello, Mikhail.
So thank you for joining us once again, and it was pleasure previous time to see all of your talks. And today you are going to talk about the present of software testing with AI, right?
Yes.
I have one question in my mind that really bothers me when I thinking about AI. Do you have anything in your talk about how to find a job, how to pass a technical interview?
I think it's possible. Some people are already doing that. In this talk, I will not mention about it, but I know that it is possible in different ways.
Awesome. Sounds good. There is some chance for, on competitive market, it's a chance to find something good. But nonetheless, can you talk us a bit about what's going on? What's the present of software testing?
Like every day and day, the software development is getting more complex and complicated. We are having several challenges, difficulties, problems. So all these problems apply to software testing as well. So the products that we are testing are not easy. We are having time pressure. We are having too many difficulties and problems. I will talk more detail in my talk, but it is every day we are facing different problems.
For sure, definitely agree. Before you start, I need to mention a few things to our audience. Guys, please don't forget we have a discussion zone after the talk. And also, while the talk, you can ask your question in the chat. So we would like to see some of your questions. If you're not comfortable to speak in or ask questions in English, you can write them in Russian, and then I will translate. I mean, Друзья, если вы стесняетесь задать вопрос на английском, вы можете написать его на русском, и я переведу его Месуту. Так что будем ждать ваших вопросов в чате и в конце в дискуссионной зоне. Yep, and now it's your turn.
Thank you so much. Thanks for the warm introduction. My name is Mesut Durukal. I'm a software test engineer, test automation engineer, and today I will talk about feature of software testing. Like this was my title previously, but I feel like the features already today, so we can already talk about the present of software testing with the help of machine learning activities, how we can leverage machine learning into software testing. Before further moving on, first of all, let me a little bit introduce myself. First of all, this is, I guess, if I'm not wrong, the third time I'm presenting in Heisenberg. So I guess I feel like it is already time to greet all the audience in Russian. So I'll try it now. Siam Privyet. So I hope it was correct. And for now, this is all I can speak in Russian. But I hope I can present more in Heisenberg in the future, and maybe I can learn more. So, as I told in the beginning, I'm a software test automation engineer, and to automate our activities, to reduce the manual efforts, we can use machine learning activities. And the main theme of the talk today will be this leveraging machine learning activities into software testing lifecycle in different stages, starting from the designing of test cases, and then we can implement them, we can automate the test code, and then execute them, and finally do some maintenance activities. So in all these stages, we will go one by one and try to investigate in what ways we can leverage machine learning in these stages. In our initial discussion before the talk with Mikhail, like there are several ways to use machine learning, like for job hunting and even in your daily life. There are several ways to use machine learning, but why don't we use as software testers as well, right? If everyone is somehow trying to leverage, then we can also do that in our daily activities as software testers. So this will be the main theme. And what will you see as the sections is, first of all, I will talk about the need of using machine learning. As we already actually start discussing about this, what is the need and why we are looking ways to leverage machine learning. And then I will do a quick reminder, like to explain what is the quick background of principles of machine learning. And in the second section, this will be the main part, we will go over all the stages in the software testing lifecycle. As you all know, we start by analyzing the requirements. We design test cases and we go over until the closure, which is the maintenance stage. And finally, in the last part, I want to explain one example, which is a practical study I tried in my personal project. I tried to do a classification on the bugs. Sometimes we report bugs, we have several issues, bugs, tickets, right? So they have different severity levels, severity 1, 2, 3, 4, whatever. So whenever a new bug is reported, is raised by someone, what should be the severity level of this bug? So this is a classification problem. I tried to do that with the help of machine learning algorithms. So I will explain and we will see how it works. I will share some results and some data regarding this study. So let's start with the introduction. Why do we need to use machine learning in our activities? Because again, we discussed in the beginning very briefly, but we have several challenges. Like nowadays, the applications that I'm testing are too complex and complicated. It is not only one interface, there are several interfaces, and they are installed in several platforms. There are too many integrations to different applications. The applications are talking to each other, communicating to each other. There are APIs, UIs, several interfaces. So the scope is very wide and comprehensive. Scope is very comprehensive. On the other hand, time is very tight. I have a very limited testing time, testing window. Like sometimes they say that the deployment is ready to test, and we have maybe 2 days. Like the development activities was maybe weeks, 3 weeks, 4 weeks, whatever, or maybe it spent the whole sprint. But we have only 1-2 days for testing. So it is not easy, and we try to automate everything as much as possible. Of course, we will always need some manual testing, but on top of that, we for sure need some automation. Otherwise, with only manual efforts, it's not easy. So challenges are too much, too many, and it might look a little bit scary. We might feel a little bit desperate because when we feel stress against the challenges, we might feel desperate, but these challenges force us to find different solutions, different approaches, right? They enforce us for looking for new solutions. So we are looking for some new solution. We are looking for some help or support to get from someone or something. And who can be the person or the target that we can ask for a support or help? Maybe machines. I think they can help, right? Because can they help? Maybe when we look to our daily life activities, we can already see that they are already helping us in lots of different ways. Whenever I'm reading an article, the platform that I'm reading my article is already suggesting some more resources. It is doing some proposals, like it says you might be interested in this article as well. Why does he know? Why does it know that, or how does it know? Because it learns my patterns. It observes my patterns, the resources that I'm interested in, and it knows me very well. It learns me. And after learning and observing my patterns, it is starting to produce or generate some estimations or predictions. So this is how machines work. So since it is working in lots of different ways in our daily life, so maybe we can integrate this in our testing activities as well. So a very quick reminder about the principles of or the working ways of machine learning. So as you all know, data is very important. First of all, we need a training data. And then by observing this training data, we have to train the learning algorithm. And the learning algorithm will generate a model. This will be our prediction model. And whenever we have some new upcoming data, based on this upcoming data, the model tries to predict what will be the outcome. It will do some predictions. And in the training stage, if we are already satisfied with these predictions, if we think that the performance is already good, then we can already let it go to production environment and start using. Otherwise, if we think that the performance can be improved furthermore, then we modify our model, improve model, and do the training again and again until we reach to a satisfactory performance level. So this is how machines work, or the machine learning algorithms work. So the training data especially is very important. If we don't have enough data to reflect all the patterns, all the maybe the order of the actions or the behaviors, then the model cannot be generated properly and the predictions will not be accurate, most probably. And if we compare with how our biological learning works, it is very similar. Like as human beings, we also learn, right? We have brain, we collect some different symptoms, some different signals, and we process over our neurons. We have a neural system, and it works very similarly with how the neural networks work. For example, I have a example on the slides explaining how we recognize objects. For example, if some object is coming towards me from a far distance, far away, like let's suppose it's a cat. So how I recognize it's a cat? I generate some different features. First of all, I evaluate, I make a judgment on its size. So whenever we are talking about size, it's only the feature. Or I can evaluate its color as well. It's another feature. So gradually, I make some estimations. First of all, when I check the size, I maybe come up with the result that it might not be a tiger or lion. It's not that big, right? It's small. So it might be a cat or dog. So the first evaluation is already done. And moving forward to the next grade, gradually I finalize my conclusion. So this is how it works in neural networks as well. So after a number of depth levels, the decision is finalized, and we come up with our results and the predictions. It is just an example to compare, because I shared this because when we are doing our testing activities as a human being, we can take this as a reference to generate our models. For example, as a human tester, if you ask me to test your system, let's suppose you have an online shopping website, okay, and I'm the tester of this system. So you develop this UI, you develop this website, and you give it to me. And I can start testing. Of course, I can collect some requirements, but even without requirements, I can already start some exploratory testing, right? How can I do that? Because I already learned similar systems. Like maybe I didn't test your system before, but I did some online shopping before in my previous life. So not your website, but similar website was the training data for me. So now I know how to add an item into the shopping basket. Like whenever I see a shopping cart icon, I understand. So I can collect some items into this basket, into this shopping cart. And eventually I can complete my order. So these are all my previous observations, all my previous learnings. So this is how it works. And similarly, for the machine learning algorithms, it will work by observing some images, and eventually we can do the visual recognition. In the next slides, I will show you some images about how we can train the models or the algorithms to test web applications and to locate the elements on the web pages visually. So after this first part, introductory part, let's start talking about leveraging machine learning in different stages. So this is a very usual or regular life cycle of a software testing, starting by requirement analysis, then planning the test cases, designing test cases, and then doing the implementation, the automation, which might be considered as an environment setup. And eventually, when we complete our automation, we will execute. And finally, we will see the results. If there are any failures stemming from the product, then we will raise some bugs, or otherwise, if there are any false alarms, we will fix our test code, right? So this is the life cycle. So let's see what we can do in all these stages. The first one is, after just understanding the requirements, first of all, we will design test cases to cover those requirements. So there will be a traceability between the requirements and the test cases. So requirements are already there. As test engineers, we will develop or design some test cases. So how can we design test cases? For example, I will just go right away and give you an example. For example, on the slide, I have an API example, and I have some entities. So let's suppose this is a library API, and there are some books I can query. Like, for example, whenever I send a query, I can get the list of books, or with a specific number, I can get only one book, right? So this is the get query I can send to my API endpoints. So after observing data, what I can already realize is, just looking to this data, I have some different attributes in the entity, in each book entity. For example, I have the ISBN number, I have the price of the book, I have the publish year. So these are all different entities and the attributes of the book data, book entity. And what else I can see is, there are certain formats for this data. Like the ISBN number starts with a digit, and then there is a hyphen, and then there are 3 more digits, right? This is a certain format. So I can already apply different numbers by injecting different values. So this will already generating some more cases. But alternatively, I can inject intentionally some wrong format. Like, first of all, 2 digits instead of 1, and observe what happens. Most probably it will be a wrong format, right? So most probably it will be a 400 response code, which was a bad format data or query. So, or I can see like the price should be a double value, which is a positive value. Price should be, of course, positive value. So what happens if I inject -10? The price of the book is -10. It doesn't make any sense, right? It is not logical. But I'm doing this intentionally, just for a negative test case. So all these kind of things can be, or test cases can be generated after doing the observation, which means after training our model, after learning all the patterns, all the supported data, values, or the data types. Moving on, after designing our test cases, we should generate our code, right? So how can we generate our code? So again, there will be a relation between the input and output. So on this slide, I have 2 examples. There's an input array, and after applying some processes, I will have the output. So how can I get this output from the input, provided input? I have to apply some processes or the operations. So what kind of operations do I need? As a human, it is not easy to solve this problem. Like, I'm checking the input and the output. There is no clear relation. Like, there are some initial assumptions I can make. Like, there are only negative values in the output, I can already realize. But what kind of operations should be applied is not easy to figure out immediately. But for machines, it is solved in milliseconds. It is solved in a super short time. So the operations which are needed are listed in the below image. So all the numbers are multiplied by 4, and the positive values are filtered out. So we come up with only the negative values, and they are sorted from biggest to small. So these kind of operations are made, like suppose -17 is multiplied by 4, so we have the -68, right? So all the input values are multiplied by 4, so we can see multiplication by 4 operation. So after figuring out the needed operations, applying the relevant method or the function is not difficult. We will just generate a method which will take an input and return the 4 times multiplied value of the input parameter. So the challenging thing was figuring out the operations, and for machines, it can be achieved in a super short time. And after doing that, it will just generating the relevant methods or the functions. But of course, when we are talking about UI automation, we can do some more visual operations, right? For example, when we are dealing with UI automation, most of the time, we are trying to locate the elements. For example, we are interacting with the UI, which means sometimes we are clicking buttons, sometimes we are typing in some user data, user input. So we are trying to find the text fields or the text areas, and then we are trying to find the buttons. So what does it mean? What does finding the elements mean? It means locating, right? So normally when we are doing the programming, we are passing some different IDs or XPaths. So while the machine try to parse this, it can find the relevant DOM element. But why don't we just visually recognize where the relevant element is? So there are different tools. I don't have any commercial concern, but I'm just sharing for some examples and references, right? These are not only the set of tools, there are several others, but this is just only a set of them. And this is another open repository I'm sharing because you can just go and check. It is test.ai. And you can use the code from their open repository. So basically what they are doing is they are capturing the whole screen and they are trying to locate the elements that you are looking for. For example, this is the image that I was talking in the beginning of my talk. There are several sample images. For example, if you try to test an online shopping website, then these are some different cards which can be used as a basket icon in which you can add some different items. And whenever you finalize, you complete your order, then you can you can do your payment and already do your delivery, right? So in this way, by sharing or providing several similar icons, then the model is trained. And even if you have not exactly the same, but a similar icon, then it will be recognized by the model trained with a huge data set. And not only UI, of course, there are some APIs as well you can use. For example, you can send your screenshot to the API and you can collect the results from the API. For example, I have an example here. This time it is from cloudgoogle.com. So whenever you send your query, you will get the percentages of what kind of images you have. So this is already a very difficult image, right? This is a real image. But if this is a website screenshot, you would have some icons, and most probably it would have some easier predictions. Moving on, after implementing our test cases, what was the next stage? It was execution, right? So we can already design our test cases. We can already automate our test cases. How can we use machine learning while we are executing test cases? Maybe we can still collect some data, right? For example, whenever I run my suites, I can observe different metrics, like what is the execution duration? Now I start my suite and it took 10 seconds. And then I start a second run, then it took 12 seconds. Third run, it took 8 seconds. So after a number of executions, I can already collect some metrics, collect some data, and I can do my observation already. Like the average execution for this suite is 10 seconds. Because it took 10 seconds, 12 seconds, 8 seconds. Okay, average is 10. Cool. So in one of the next executions, if it takes 30 seconds, then it will be an outlier for me, right? Because normally my expectation was 10, but somehow it took 30 seconds. Something is wrong. So normally, instead of checking all the executions one by one manually, if I execute my machine learning model, whenever it realizes an outlier, it will already notify me. So you realize I already replaced my manual effort with the machine learning algorithms. So it will automatically detect the outlier and notify me. There is something wrong in this execution because it took 30 seconds, while all the others took around 10 seconds. Please go and check it. It will already give me an opportunity to replace some manual efforts. And the final stage is the maintenance. Refactoring of the code or just doing the code review is a way of doing the maintenance in the test that we are developing. So if somehow I teach the best patterns or similar to the anti-patterns to the machines, then I can already let the machines do the code review. For example, if I teach machine that having an embedded number, magical number inside the code is an anti-pattern, then whenever I have similar anti-patterns, it will notify me. You teach me that having embedded hard-coded numbers in the code is not a good practice. It's an anti-pattern. But now I see there are some hard-coded numbers. Go and fix it. It will already do the code review for me, because otherwise the manual code review will take too much time, right? I will send to a peer in the team, and I will get the feedback. If I need any reviews or modifications, then I have to do. It will do some back and forth communication, and it will take some time. And similarly, self-healing, like whenever a test case fails, maybe the machines can already do some predictions about the reason of the failure, and it will already provide me some solutions or points where to apply the fix to fix the failing code. So this will be already one activity which will boost our efficiency in the test automation activities. And finally, my last example in terms of maintenance is the bug management. So this is the area where I will share the practical example as well. What can we do with the bugs? So we can classify them, we can cluster them, which means like classification can be done on their severity levels, priority levels, or even the assignees, right? Whenever I have to assign to someone, this is again a classification problem. Like all these class A bugs should be assigned to Mesut, or all these class B bugs should be assigned to someone else. And this is just a classification problem. Or we have to do the bug triage, like some of them will be high priority or high severity, some of them can be low priority. What is clustering? Clustering is regardless of the marks or labels, we just group similar ones. So here there is a cluster, some similar bugs. Here there is another cluster. These are similar bugs. How can we make some meaningful results from this? Like whenever I try to manage bugs, I can understand which bugs are heaping together on similar features. Like for example, for upload data feature, I have a lot of bugs heaping together on the same feature. So this is a cluster. So I can already realize how many bugs are heaped together on the upload feature. So just to speak in terms of some concrete example, let's move further on. But again, because we are mostly talking on the UI examples, another API example, we can just do the classification over an API. We can just send our natural language examples like text or the string values, and then we can have some classification results. So I'll give you a better understanding. Let me talk about the real case, real life example that I tried in my project. So in this project, I export the bugs reported in our issue tracking system, right? In this project, it was Jira, but it can be any other thing as well, just an issue tracking system. And I just export to a CSV file or just an Excel file, whatever it is. And I have 900 bugs. I know this is not a huge data. This is not enough normally. But I want to make it in real data, with real data. So I kept this data a little bit small. And from this data, for all issues, I have 3 severity levels. 2, 3, and 4. Normally, I have severity 1 as well, but none of the bugs were marked as severity 1 because normally it is super critical bugs. So in real life, I have 2, 3, 4. So three classes. And what did I do to classify these bugs is, first of all, I did a pre-processing, like I cleaned the data because I have some punctuation I don't need for classification. It is not meaningful at all. And I did some, like I convert all the uppercase to lowercase. So this kind of cleaning the text, this is the first operation that I make. Pre-processing is the first stage. And then after the data is clean and ready to use, I should extract features, right? Because normally the data in my example is just some string values and text values. Like what can be a bug? Like whenever I click a button, then the page throws 500 internal server error. Let's say this is the bug. But when I say this sentence, the computer or the machine doesn't understand anything. This is the natural language that we are using. Like I can express this statement in English, in Russian, in Turkish, in Japanese. So this is the language that we are using. But to communicate to computers, I should use another language. What language is it? The machine language, right? So which means I have to convert these text values into numerical arrays. This means the feature extraction. So if I somehow convert the text values into numbers, into numeric arrays, then it means I will be already generating some features. So what I can do, this is an approach which can be used, but there are several other approaches as well. But what I do is, in each sentence, I just count the frequency of each word. For example, this is an apple, is a sentence. So in this sentence, this word happens how many times? One time, right? There is only one this. How about is? Is again one time happening. And apple. All these words are happening one. And in my vocabulary, if I have some other words like it, they, we, whatever, they are just happening 0 times. They do not show up in the sentence. So I already have this numerical array, right? 1, 0, 0, 1, 1, completing all my vocabulary. I can already convert to a numerical array. And after doing this, the next stage is just doing the classification. So for classification, we can use several algorithms like k-nearest neighbors or naive Bayes algorithms, or like random forest, SVM, support vector machines, and several others. So what I did is I tried a few of them and I compared the results, and I picked the best performing algorithm in my problem. And let me share you some results. For example, this is the distribution of the bugs. Like I had, remember, I had around 899 bugs. So most of them were labeled as class 2. I had 2, 3, 4, right? So most of them were 2. And then 3 and 4. So what happens if I try to do the classification on this data? This is the confusion matrix, and I had around 73% accuracy. So it was not that much good. What I thought about is, let me go again to the previous slide. So there is a bias here, right? Most of the bugs are with class 2. So let's try to remove this bias. So what I can do is I can combine 3 and 4. So in this way, it will be much more balanced. But what is the meaning of combining 3 and 4? In my project, it makes sense because in my project, class 2 or 1 were the release blocker. So if it is not 1 or 2, which means the others, like I don't care whatever it is, 2, 3 or 4 or whatever. So I just combine all the others. So class 2 are the release blockers, and all the others are not release blockers. So it was important to decide if a bug is release blocker or not. So this is why I combine all these 3 and 4 bugs, and with this more balanced distribution, I had 82% accuracy. We can still discuss about the performance because it is. I know this is not perfect, but this is a difficult challenge. It is a challenging problem because even for us, like if you ask me what should be the severity level of a bug, it is subjective, right? For me, it is class 2, but for someone else, it might be class 3. So it is not super easy problem. It is a little bit difficult and challenging. And maybe the aim is not fully replace the manual effort, but doing a collaboration. This will be the final call for action as well. We will come to that point. But as I told previously, not only classification, but we can do some clustering as well. We can collect similar bugs together into some groups. So we can generate some suites of bugs, and we can try to do some root cause analysis and some different analysis as well. So I'm just wrapping up. We discussed several ways to leverage machine learning in different stages of software testing lifecycle, starting from the definition and then implementation and execution, and finally the maintenance stage. And not for commercial purposes, but just for references, I shared some tools as well. But please do not stick to different tools, right? You can even develop your own solution as well. It is just coding, and there are several open libraries. Like if you use Python or you can use different libraries. So if you search for your specific problem, you will find several example solutions, and you can develop your solution. And the final call for action: can we replace our effort, manual effort, to the robots or the machine learning algorithms? This is a very hot topic, right? Everyone is discussing. Like some of us are already, even as software testers or the developers, we sometimes feel even scared, like we might lose our jobs. Machine learning is coming. Everyone is working on machine learning, and all the managers are looking ways to replace human engineers by machine learning algorithms. Will this be the case? I mean, we can replace some of the activities with machines, but some of them, right? Because the final decision, especially for software testing, we are talking about usability, we are talking about human feelings. So it is not easy to replace everything by machines, but why not just a competence, but why not doing a collaboration in terms of competing machines and humans? So we can collaborate, we can get support from the machines, and by this way, we can already improve our test executions, and we can improve our efficiency, so we can have more time to do some more improvement activities. Like for exploratory testing, we can spend some more time since we already replace our manual efforts with the machine learning activities. So this would be the last call for action. Please try to find ways for collaborations, and I guess we can have more discussions if there are any questions. But before that, just thank you for listening to me. And again, closing in Russian, I want to say спасибо.
Спасибо, Mesut. Thank you, Mesut, for the great presentation. And we have some questions. But for the beginning, I need to mention that our audience need to rate the talk. Друзья, прошу проголосовать за выступление, которое вы только что увидели. Здесь в окне есть, там можно поставить звездочки, и не стесняйтесь поделиться своими мыслями. Организаторам конференции и особенно Месуту будет очень полезно узнать о том, что вы думаете о докладе. То есть это может быть как просто поставить звездочки, так и добавить комментарий. Пожалуйста, не стесняйтесь, это будет очень ценно для нас всех. So let's go to the question. I just mentioned that it's really valuable to see some feedback from the audience. It's valuable for organizers and of course for you, because probably this talk can be improved in the future according to what feedback people are giving. But for the beginning, I have a question regarding, what you just said and what your examples of your AI tools you showed. For example, if we are talking about test case generation, how good is, let's say, this test AI in real life examples? Have you tried on on real project?
I did not try that one, but if you're asking for any tools that I used, like I tried, of course, ChatGPT, as
Right.
everyone else. So it generates really very accurate results. Like I'm explaining a problem, like this is my use scenario. Please design some test cases for me. And it already provides a number of, like not only one, but a number of, including the corner cases, the negative test cases. It generates really very accurate results.
Because as you mentioned, ChatGPT, probably everyone already noticed few, passed through stages while using this technology. First stage, it would be, wow, that's awesome. It can change, it can replace the people soon. Then you see like it's not so perfect, and you still can use part of this, but maybe you also need to refine your prompt, and then you will see some result that you probably can use, or you also need to work around this. So I'm also interested about the tools that you're suggesting to try. whether it works as well, or we need to like still use our brain to get some valuable results.
Yeah, of course, of course. That's definitely true. Like this is what I tried to say in the closing note. Like, of course, machine learning can produce very valuable results, but as you highlighted, sometimes we have to work around that on top of the results because we need a natural intelligence, not an artificial intelligence, right? Because, okay, whenever we describe a problem, then it can come up with some solutions. But you know what? The most important thing in solving the problem is figuring out the problem. I am the person who is explaining the problem, right? And then machine learning is generating some solutions. But can machine detect the problem itself? Maybe not. This is the natural intelligence. So in that regard, I guess we will always need the human intelligence. And even on the final results, I think we as humans should do the final conclusion, I guess.
Yeah, right. Thanks. We have still a few minutes in the presentation. I will ask some questions from the chat, and then we will move to the discussion zone. So first of all, people are saying thank you for the talk and for example that you give us. It was about people like your examples regarding shop web page, and also some people like your example about cat. And so next, the question is: when we get the result of our exploration, we have probability of truth. Can we? So how can we trust this data? I mean, from we got from exploration testing.
Again, I would say it is not possible to trust 100%, but at least we can get some initial results. Like, first of all, for example, in my bug example, real life example, of course, I will not do the bug triage 100% based on the results coming from the machine learning algorithm. But I can already have an initial assumption of the bug triage. So on top of that, I will do my final conclusion as a human being, but it will already facilitate all the processes because, for example, if I have 1,000 bugs, I cannot check all of them one by one, right? But machines can do that in a very short time. So this will already facilitate all the process. But again and again, I'm repeating myself, but the final conclusion should be done by ourselves.
Yeah, right. That's totally true. But yeah, also people were asking about list tools that you are having in mind. So probably for answer these questions, guys, you feel free to download the presentation and the slides from our website. It's already there, and you can scroll through, find all necessary information, all examples of the tools, and also if you missed something or you just would to repeat yourself, you also can go through and find answers for answer your questions regarding the talk. But we will answer more your questions. Feel free to post it in the chat. And so far, we are almost done in our time slot. Thank you so much. And Mesut, thank you. And we will continue the discussion zone.
Sure. Thank you.